right, so now I'm going to review substitution. So substitution is when you're plugging in for variables. So let's look at this system right in front of us. So in this system, you have your x by itself and y by itself, right? So this is telling us right over here is that wherever we see x and y, we want to use the equations that they equal to. All right, so let's say, for example, I want to try to take negative 5y minus z is equal to 25, right? Wherever I see a y, I'm just going to plug in 5x plus z minus 4. So I have the y, sorry, I have the negative 5, and I'm going to plug in this 5x plus z minus 4 minus z right over here is equal to 25. Okay, so then let's go ahead and distribute. So we have 5 times, negative 5 times 5, zx is just negative 25x. Negative 5 times z is a negative 5z. Negative 5 times negative 4, that's a positive 20. We have a minus z is equal to 25. So I just distributed over here, and I could go ahead and combine those like terms. So negative 5z plus minus z. I'm going to bring down that 25x. If I combine those two together, we should get a negative 6z. And then we have a 20, oops, and equals to 25. Now, again, before, we've said this already, we wanted to get the variables on one side and all the numbers without variables on the other side. 20 is the only thing without variable, so I can just go ahead and subtract it away from this side. So I'll just get negative 25x minus 6z is equal to, this is 5. Now, this doesn't tell me anything because we still have that x. But remember, in our original equation, x is equal to this, negative 4z minus 19. So again, I might need to substitute again. So I'm just going to rewrite this over here. Negative 25x minus 6z is equal to 5. And instead of writing x, I'm going to write negative 4z minus 19 minus 6z is equal to 5. Right? So I just exchanged that x for that equation, and I can go ahead and distribute. So negative 5 times 4, that is 100z, positive 100z. Negative 25 times negative 19, that is positive 475. And then we just have that 6z to bring down and that 5. Now at this point, we can start again by combining those like terms. So right over here, you have your z's on the same side. So let's just go ahead and combine those together. So 100z minus 6z, that is 94z. 475 is equal to 5. I can get the 475 to the other side. Oops. By just subtracting. And yeah, we're going to get a negative number. So 94z is equal to 5 plus negative 475. And this is just negative 470. And you want to divide both sides by 94. z is equal to -5. Okay, so now we have that value of z, and we can go ahead and just find the other values. So here, it's easier for us to find the value of x because z is just there. We have it's set to a value of z. So let's go ahead and do that. Let me just write it over here. X is equal to -4 times z minus 19. Instead of writing z, we're going to put -4 times -5. -4 times -5, this is a 20 minus 19. And x is just equal to 1. Okay, so now we have these two variables. I can go ahead and find for y. So if we're trying to find y is equal to 5x plus z minus 4. You just want to replace this. So instead of writing x, we'll write 1. Instead of writing z, we'll write -5 minus 4. You can multiply 5 times 1 is just 5, plus -5 minus 4. These cross out, and you're just left with y is equal to a -4. So those are your three answers. You have a 1, you have a -4, and then you have a -5. That's your system right over here. Right? So we're just replacing over and over again so that we are able to find those values. That's what substitution is. Now sometimes you'll get substitutions like this, right? Now again, the idea is going to be the same. You want to solve for one of the variables. So between equations 1, 2, and 3, 3 is the easiest to find because it's just 5a is equal to 30. You can find out what that a is. So let's go ahead and find out what that a is. 5a is equal to 30. You divide 5 on both sides, and a is equal to 6. So we have one of the values already, and we have to be mindful where we plug this in. If I plug it into the first one, I still have the b and v to worry about. But if I plug into the second one, I just have that b alone, and it'll be easier for me to find what that b is. So let's go ahead and do that. So this is equation 2. Let me just rewrite it. 4a plus b is equal to 25. Instead of writing a, we'll write 6 plus b is equal to 25. 24 plus b is equal to 25. Subtract 24 on both sides. B is equal to 1. So, oh goodness, we found two variables, a and b. So now we can find that third variable. We can just plug it all back into, so this, we'll plug it into that first equation. So let me just go ahead and rewrite this. First equation, 4a plus b plus 3v is equal to 31. We'll just have 4 times 6 plus 1 plus 3v is equal to 31. 24 plus 1 plus 3v is equal to 31. Okay, so these two are like terms. So this is going to be 25 plus 3v is equal to 31. Subtract 25 on both sides. And then you would have like 3v is equal to 31 minus 25. This is 6. So you can get v alone, and v is equal to 2. All right, so now we have all our values. A is 6, b is 1, v is 2. That's your whole answer for this one. All right, so So let's try, okay, so hold on a sec. Just like before, we just put it over here. This is the part of the video where you can pause and try to figure out what this answer is. So this is a lot similar to that substitution problem we just did. Pause it, try it for yourself. Oh, sorry, pause the video, try it for yourself. And then this should be your answer right over here. So if we, weird, just move that. Oh, that was from, oh, I get it. There. All right, so with this one, we start off finding what b is by itself, which is 3. And then wherever we see b, we put in we put in 3. We found that v is equal to 6. So we plugged it into here. And then we were able to do inverse operations to find that, oh, how did this get over here? Oh, to find that sorry, let me just put over there, x is equal to 2. So we would have this system right there.